In the realm of hypercar engineering, weight is the eternal enemy of agile performance. Yet, Bugatti built its modern legacy on the shoulders of a mechanical giant, the quad-turbo 8.0-liter W16. Engine, this powertrain is a Leviathan, typically housed within a 2-ton chassis, draped in opulence and sound deadening. The central conflict arises when engineers attempt to transpose this heavy industrial heart into a chassis governed strictly by track-only physics. It is a violent clash of philosophies, heavyweight luxury grand touring versus raw, unadulterated downforce. Now let's open the factory blueprints and deconstruct the story of this engineering titan. When we analyze the initial design brief for the Bolide, we find a radical departure from Molsheim's traditional constraints. The engineering problem is stark. The W16 powertrain, along with its dual-clutch transmission and fluid systems, presents a massive, fixed weight that cannot be easily reduced. In the standard Chiron, this mass is managed by adaptive suspension and compromised by the necessities of road legality. For the Bolide, the objective was to achieve a weight-to-power ratio approaching the mythical 0.67 kilograms per horsepower. This required stripping away the very identity of a Bugatti road car. We see that the challenge wasn't simply removing leather and air conditioning. It was a fundamental thermal and structural crisis. How do you package in one 850 horsepower furnace into a shell that must corner like an LMP1 prototype without melting its own composite skin? The solution required discarding the existing structural strategy entirely, forcing the team to build a new cage around the beast. To solve the crisis of mass, the engineering team at Molsheim could not rely on traditional casting or milling techniques. The hunt for a solution led them away from standard automotive manufacturing and directly into the realm of aerospace grade additive manufacturing. When we observe the assembly of the Bolide suspension components, we are witnessing the apex of selective laser melting. The engineers realized that to cage the W16 effectively while shedding weight, they had to mimic biology. This approach is most visible in the push rods. In a standard supercar, these are solid forged aluminum or steel. In the Bolide, they are 3D printed titanium, weighing a mere 100 grams, yet capable of withstanding a buckling load of 3.5 tons. Factory analysis reveals that these components utilize an internal structure resembling bone, marrow, hollow where mass is unnecessary, dense where stress vectors converge. This is bionic optimization, a manufacturing process that places material only, exactly, where physics demands it, shaving grams that eventually tally up to hundreds of kilograms. The assembly process then moves to the braking system, another critical junction where heat management dictates design. We see the installation of completely new calipers, also 3D printed from titanium and coated in ceramic. Unlike the road-going Chiron, which utilizes massive airflow to cool its brakes, the Bolide requires a system that functions under the extreme thermal cycles of a track session. To achieve this, the engineers designed a turbofan radial compressor mechanism in carbon fiber wheel covers, actively extracting heat from the discs. It is a closed-loop thermal strategy that allows the braking system to remain effective, even when the rotors are glowing at temperatures that would vaporize standard fluid. However, the most radical phase of the manufacturing hunt occurs above the cockpit. The Bolide features a morphable skin on its roof intake scoop, a patented innovation that challenges our understanding of active aerodynamics. At low speeds, the surface is smooth, but as the vehicle accelerates, the surface bubbles, creating a field of dimples. similar to a golf ball.
By introducing
When we
these
interpret
dimples,
the wind tunnel
turbulent
data,
boundary layer is
the
energized,
genius of this
resulting in a
feature
significant
becomes
reduction in
clear.
drag.
These dimples create localized turbulence that energizes the boundary layer of the air, delaying flow separation and reducing aerodynamic drag by 10%, while simultaneously optimizing the airflow into the hungry W16 intake and onto the massive rear wing. This isn't just styling, it is an active manipulation of fluid dynamics achieved through a flexible composite membrane. The assembly of the rear wing itself is the final piece of this aerodynamic puzzle, mounted directly to the chassis rather than the bodywork. The central fin and strut assembly are designed to transmit nearly 3 tons of downforce directly into the rear suspension, bypassing the body panels entirely to prevent structural deformation under load. The culmination of this manufacturing hunt is a machine that achieves the near impossible figure of 0.67 kilograms per horsepower. When we review the final validation data, we see that the Bolide sits at a DRI weight of just 1,240 kilograms, lighter than many compact sedans, yet possessing the power output of 2 Formula 1 cars. This figure confirms that the bionic titanium structures and the radical deletion of luxury systems were not vain exercises. They were mathematical necessities required to balance the equation of speed. The chassis meets the stringent safety requirements of FIA LMH regulations, proving that the structural integrity was actually increased despite the aggressive mass reduction. We see telemetry data indicating lateral acceleration capabilities of 2.8 G, a realm previously exclusive to dedicated racing slicks and prototype chassis. This vehicle stands not merely as a track toy, but as the ultimate vindication of the W16 platform. By liberating the engine from the constraints of road legality and acoustic comfort, the engineers have allowed the powertrain to reach its theoretical potential. It is the W16 in its purest, most violent form, finally unburdened by the heavy compromises of the Grand Tourer. Ultimately, the Bolide is more than a collection of carbon fiber and titanium. It is a defiant roar against the dying light of the internal combustion era. It represents the absolute limit of what human hands and minds can extract from gas and air, standing as a timeless monument to the sheer audacity of mechanical engineering at its absolute apex.